This project is concerned with the NAE Grand Challenges. The Grand Challenges are a set of fields of engineering in which we attempt to resolve many issues. The field of engineering that we picked was making solar energy economical. As of now, solar energy is very limited, primarily by storage and production. Compared to other non-renewable resources, solar energy does not produce enough energy, and that energy that is produced through solar energy is very hard to store and give to other sources where it must be consumed. This project will attempt to find ways to make solar energy more economical, primarily by looking at classes of solar energy production in different countries and seeing where they are more efficient and where and how potential investors could use that information to make more efficient solar energy production sites. The formula that this project will attempt to use is this one. This one takes into account productive land, energy produced, as well as the conversion efficiency given here, and the number of days needed for production. We already know how much energy is going to be produced for respective classes. So instead, in this project, we're going to take productive land and attempt to find that through energy and compare that to other sites where there are different classes from 1 through 10 and see in which area energy is most efficient. These are the two main equations that this project will use, and this will hopefully help potential investors find a more productive way to store energy. This is the algorithm sheet for our project. The summary is stated here, and it says that we try to find the percentage area per country per class compared to the class number. And this way, we'll try to find the percentage area for class that is the highest, and so potential investors could use this to find the most efficient way to produce energy. Our input values are class efficiency and energy produced per day, and we're trying to find the percentage area, our y-axis. This will be the formula, the main formula that we will be using. We will of course be finding productive land, and so we will be solving for productive land with the energy and class efficiency. This is the algorithm sheet, and this is the list of the algorithm, and this is implemented in our Matlab script. So first we have our housekeeping commands. Then we export our Excel sheet into Matlab. Here is our Excel sheet. We will assign the table, the values from the table to different variables. So this name is under country, and then table will have the three important values we need: the class efficiency, the energy, and the class itself. We will then use an if-else statement to turn the class number into the efficiency value that we need. Now, this Excel sheet only listed the range for the specific class value, so we had to assign an average value with our Matlab script to each efficiency value. This is a limitation as we couldn't give an exact efficiency value. Then we used our first function, area, to find the percentage area given efficiency and energy. And here's that equation that I first mentioned. This function finds the percentage area for class for the country. Next, we have to split up the table into each country. Now, this is an example of hard coding as we listed exact values. This is another limitation in our sheet. we then used the percentage area function by plugging in the areas, the percentage area found above here, and using the area found to find the percentage area. The percentage area function is very simple. It has area and total area. So the area represents the area for a class, and total area represents the whole area for all the classes combined. Once we did this, we had found the value that we were trying to find, percentage area. After we did this, we plotted this in 16 different graphs, as we were doing 16 different countries. We specified titles, axes titles, and so on and so forth. After this, we gave the user the ability to find the percentage area if they enter the class and the country through the menu function. For our Matlab project, we picked the following 16 countries. We picked these 16 countries because we believed they represented the most variety in terms of geographic location, as well as how well off they were. For example, the United States and the United Kingdom are first world countries, however countries like Pakistan are third world countries. This also introduced a level of variety in terms of how much production was available. So for these countries, we had to unfortunately hard code them when we exported them from Matlab due to our limited knowledge in the Matlab class so far, as well as the fact that they were written in an Excel spreadsheet, and it's very difficult to export them without hard coding. However, we did use two functions that eliminated as much hard coding as possible and really represented a way to be able to recreate this data in a very concise way. So the 16 countries that we had up until this point were hard-coded. However, we did use the two functions that helped expedite the process. Then they were, with the subplot command, put into different figures, and now I will attempt to run the program. So here are the 16 different countries. As you can see, there doesn't appear to be a particular trend. That's why no trend lines were applied. Some countries have perhaps a power function that could be applied, and some even a parabola, but no specific trend line could be applied that was applicable to all countries. Additionally, to help the user, we added two menu options with if statements. This could help the user identify a particular percentage area for a country and class. So if we go to the United States and pick a class of 8, in the command window, this is outputted. In USA, class 8 occupies 2.11% of the area. Additionally, since not all classes have values given for their respective countries, some countries may not have a class of 1 or 3. We also attempted to put an error command in the menu and if-else statement. So if we were to pick Saudi Arabia and pick a class of 1, this following error would appear. Unfortunately, this data was limited by many reasons. The class for all countries wasn't always available. Additionally, we were forced to choose an average value for class efficiencies depending on the class, as well as the fact that this Matlab function was slightly hard-coded. However, there are two functions that are used, area and percent area, that could help people solve the question that we were attempting to solve with this Matlab script. They could use more data to further gain information. There unfortunately doesn't seem to be a trend, but yet again, um, potential investors could look at particular graphs and find which ones occupy the highest percentage area, and from this um, attempt to put the class value for that function.